Hello guys, welcome to Ramta Solutions and welcome to your grade 10 quantitative aspects of chemical change. Today we are looking at your theoretical and percent yield. So at the end of this video, you should be able to use this formula and to understand every part of it. Okay, so without any waste of time, let's get into it. Now, when we talk theoretical yield, we are basically saying the mass of the product formed. So basically, this is the mass which we obtain from stoichiometric calculations. Remember, from stoichiometric calculations, you get number of moles of your product, right? You get number of moles of your product. So what you will then need to do is you will need to convert those number of moles into mass. Remember, you use the formula N equals M over mass star, right? So so when we talk of the theoretical yield, we are talking of the yield which we obtain from stoichiometric calculations. So that those quantities of your product that you calculate using stoichiometric calculations, referring to your chemical reaction, it is your theoretical yield. Now, it is different to the amount that we obtain when we are doing experimental work, or if this was a plant, it is different to, let's say, chemical process. The theoretical yield is different to that amount that we get when we are actually in the laboratory or in the chemical plant or chemical process. Okay, so this amount that we obtain from experimental work, we call it the actual work. Okay, so what we know, or rather observation, is that this theoretical yield is mostly greater than the actual yield. It is never less than actual yield. Okay, it is never less than the actual yield. It is in fact greater than the actual yield. Why? This is because, as is the case, sometimes the reactants do not react completely, and sometimes you may find unwanted products. This is to say, there can sometimes be side reactions. Okay, there can sometimes be side reactions, which are reactions that you do not want. And sometimes, though there was a reaction, you find that when we are now recovering our product, you find that we were not able to recover all products from the reaction mixture. Right? So this is why we don't always get 100% of the we don't get the actual yield as the same way as, or we don't get the same actual yield as the theoretical yield. It's because of these three reasons. Okay, it's because of these three reasons that the actual yield will be less than the theoretical yield. Remember, we're saying that the theoretical yield is mostly greater than the actual yield. What does that mean? That means the actual yield is less than the theoretical yield. So we can relate the theoretical yield and the actual yield by using the percent yield. Okay, by using the percent yield. Okay, so the percent yield will tell us how efficient a reaction is. So if you are a boss of a chemical plant, or a manager of a chemical plant, when your engineers are designing a plant and you're getting percent yield that is very low, you know that that is not a process that you should embark on. So without any waste of time, let's now get into that formula that we had in the opening slide, this formula here. So we said theoretical yield and actual yield can be related using the percent yield. So now let's talk about it. So now, what is this percent yield? So this percent yield, it is basically actual yield over theoretical yield. Okay, it is actual yield over theoretical yield. And of course, you can multiply by 100 because you said percent. All right, theoretical yield. Okay, multiply by 100. Okay, so this is your theoretical yield. I mean percent yield. Remember, the actual yield is that one that you get actually, the one that you get from experiment or from the process itself, the actual process that's running, or the actual chemical process that's running. And the theoretical is the one that you get from stoichiometry. Okay, I repeat, theoretical is the one that you get from stoichiometry. Okay, from stoichiometric calculations. Okay, perfect. Now let's try an example. And by the way, guys, I want to emphasize this. I said here, theoretical yield is the yield. In brackets, it is the mass of product formed, because we're referring to the desired product. There can be undesired products, right? But here we are referring to the desired product. Okay, perfect. So now let's try an example. So the example will be like this. Kenneth uses the following reaction. Kenneth uses the following reaction. Okay, uses the following reaction. What is the reaction? 2 beryllium solid plus oxygen gas. I'm trying to balance it immediately. Gives us 2 beryllium oxide solid. Okay. So what he does, he calculates that he could produce 1.5 grams of beryllium oxide. Let me write that down. He calculates that he could produce 1.5 grams of beryllium oxide from beryllium and oxygen that is available. Okay, that is available. Okay, now the question is, what is the percent yield? Okay, what is the percent yield? What is the percent yield if experiment? Okay, what is the percent yield if the experiment he ran, I'll go to the next page, if the experiment he ran produced 1.4 grams of beryllium oxide. 1.4 grams of beryllium oxide. Okay. So now we're going to find our solution. Okay, let me do this. So let's go back. Now we have key points here. Kenneth uses the following reaction. He calculates that he could produce 1.5 grams from this. He calculates, highlight this, he calculates that he could produce 1.5 grams. So what is this? And then I'll be back to this. And then what is the percent yield if the experiment produced 1.5 grams? If the experiment produced 1.5 grams. So now we have to ask ourselves questions. What are these values? So what is this? This must be the theoretical. Sorry, yeah, it is the theoretical. Okay, it is the theoretical. Why am I saying theoretical? Because he calculated it. Okay, and of course, this 1.4, what is it? It is the actual. Why? Because it is what he obtained from the experiment. Now let's get our answer. So percent yield is equal to actual yield over theoretical yield over theoretical yield, all multiplied by 100. What is theoretical yield? It is 1.4%. What is actual yield? It is 1.4%. What is theoretical? It is 1.5%, all multiplied by 100. Now what do we get? We get 93.93. 93.33%. Oh, if I am a plant manager, I can do with this, I can do with this. As you can see, this is not far from 100%. So it means I'm not losing much of my material. I'm not losing much of my beryllium. I'm not losing much of my beryllium. And I'm also not losing much of oxygen. So it means I should trust my engineers. They are the best. Okay, so guys, this is how you calculate your percent yield. Okay, this is how you calculate your percent yield. So with that being said, our ends here, and I hope you guys enjoyed this. Because you're watching this video on YouTube, you may subscribe, and please subscribe, like and share the video with your friends, classmates, and everyone in your circle. And if you go to our website, by the way, you can visit our website, https or www.ramtasolutions.co.za. You will see these icons at the top. You can click on any of them to follow us. And also you will see this one. If you're looking for a tutor, you can click on this one. This one will guarantee you a quick response, and this one we will also respond to it. We will respond to both of them. Okay, so if you're looking for a tutor, you can talk to us on WhatsApp, or you can email us, whichever you prefer. Okay, so with that being said, guys, we wish you all the best, and bye bye.